Good morning, JFall. Happy that you're here that early in the morning and that he's not got stuck in the traffic and the entrance. I want to talk about process-oriented system integration, kind of probably a clumsy title, but a super interesting topic. And if we look in most of the organizations today, and that might be true for you as well, I've seen that quite often that we have a lot of legacy systems. Obviously, that's what we have in the organization. I'm taking a banking example today from finance, basically around opening a new bank account. You can transfer that in your head to whatever industry you're working on. I just have to pick one for the talk. And then you might have a couple of systems, and very often, of course, you have certain things automated in there. You're not doing anything, everything manual, but you have it automated. But very often in a, let's say, a point-to-point way, you have this kind of integration, you have that script there. I just recently saw a PL/SQL script in the database calling a SOAP web service, which is kind of where I have no words for. And I call that the spaghetti integration. Not only I call that, I think that's what you all know, right? That's a big pile of spaghetti. It somehow integrates these kind of systems. Very often you also need additional manual intervention if something goes wrong, or probably to sort out things. And that was a surprise to me, actually. Beginning of this year, I opened a new bank account for a big German bank, and it took 6 or 7 weeks, actually, to finish opening a normal bank account, which was interesting to see that. And I also asked a couple of times, so there was, I think, some manual things involved. And that's really a big problem. And if you look at those integrations, and if you look at, for example, processes, so I'm a process person, if you look at the processes behind, very often you don't look at the end-to-end of things. So integrations are very often really point-to-point. I look at that specific integration, but not the overall process from, if I look at onboarding, for example, from I enter my application till the bank account is opened and I have the details to access it. That's very often broken. We concentrate on local automations very often. That also leads to a lack of understanding, like how is the process really implemented? Why does it take 6 or 8 weeks? Where are the typical problems that we need to solve out? And if I don't understand how it's currently happening, it's also super hard to change or to fix. So very obvious is we need to fix certain problems. That's not possible, but also I stumbled upon a lot of cases recently where organizations want to try out AI, for example, for certain use cases, but it's not easy for them to know where to plug it in, because where in that spaghetti should I like do something? That's where process orchestration comes into play. If you look at process orchestration, you have these kind of processes. That's BPMN. I show you that in a minute in more depth. Who does know BPMN? Just to make sure I'm not explaining the obvious. Okay, I'm looking at that in more detail in a minute. It's an ISO standard to define these processes. And there you look at process automation very often in the context of integration. If I say process automation, and I find that important, it took me a while actually to understand that this is a common misconception we need to fix. If I say process automation, for example, there are 2 ingredients involved here. The one is we might want to automate certain tasks within a process so that not a human is entering all the data, but it's probably going via an API. Or that you use robotic process automation to steer an user interface, or that you simply code certain things that you don't have to do it manually. But that's very often a specific single task within an overall process. And the other topic is the process orchestration topic, which basically cares about like what tasks do we want to do in which order. And like what rules do apply that I go this or that way, right? So there are 2 topics involved. When I say process automation, typically involves both, and it's important to be clear on what you're talking about. And if I look at integration, and personally, I look very much at process orchestration, so the overall like what has to happen, and that's an integration topic, because if you look at these processes, and there might be end-to-end business processes, but also very often there are smaller processes, just whatever, handling certain aspects within the company, then this is about integration, because you have to integrate a lot of different what we call endpoints that might be humans. Then you have a task list, for example, or you whatever, involve them via Slack. And you, of course, have all the technical interfaces like a REST or messaging or SOAP or what have you, right? And these needs to be integrated. And that's interesting, actually, to look at. If we're Java engineers, which I assume most of you are here, that would make sense at least, then it's normally like, okay, that's no problem, we can code that. I mean, we can write code in order to integrate all these kind of protocols, these kind of systems, no problem. And yes, that's doable. And I show you that in a live in a second. Just the last slide before going into that thing. If we have a BPMN model, and a lot of people, when I show these graphical models, connected to some kind of whatever low code or model-driven approaches, which very often they don't like too much. But if you look at certain tools, and we are, for example, one of them, then you can simply connect code to these models. So you could say, okay, in order to add the customer to the CRM system here, we want to connect code, which we write in Java, and that's a Spring example. So our Spring integration have all these kind of nice little annotations, which we look at live. In order to write, basically hook in the code I need for doing REST calls, and I might write code in order to expose an API to the outside world, and then use the API of the workflow engine, of the orchestration engine here to kick out things. Okay, does that make sense? Awesome. Let's look at that. And the example I'm showing here is also available on GitHub if you want to play around with that later on. I'm also at the booth later if you want to ask me any questions about it. And let's move over to my IntelliJ here. So what I have is a normal, in my case, Maven project. So simply a normal thing here. I have basically, I'm using Spring Boot. And what I have is one additional thing, which is somewhere here. So I have a Spring Boot starter, in this case from Camunda. I'm using Camunda. I'm from Camunda, so that's probably not a big surprise. It's a source available process orchestration platform. I'm using a client here, and what I use as well, I'm using a SaaS version of Camunda. So you can also get a trial account. You can run it self-managed as well, so you can start it up by a Docker, for example, but I'm using the SaaS version. And then I have an orchestration engine in the background, which I can connect to now using some kind of API credentials. So I'm not going into all of those details, but that's basically what you need to do. You need a client API, you need the credentials. Now I can access it. And then you can define these nice little BPMN files, which I showed you earlier on. A BPMN is not a big magic thing. It's basically an XML file, but it can be rendered graphically. And then you can attach certain information to that. So for example, in order to create the customer in CRM system, I have a so-called task type. And this is my connection to my code. I could use different languages here, but I'm using Java, obviously. No, that's the wrong one, this one. And there I have a so-called job worker that's connecting to the orchestration engine, saying, hey, I can do tasks of type A customer to CRM, and then you do whatever you need to do. In my case, I'm just using a Spring REST template. Is that understandable so far? Nodding people, that's good. Let's look at how that looks from the user perspective, personally, probably. So I'm running the application in the background, and as you can see, I'm a UI developer. That's what I can do best. So I created that great, awesome UI to open up a bank account. You have to provide no data. But if I click here, and why do I do that? That's stupidly because I like that you can show how easy it is. I'm basically just using jQuery to send a REST request to a REST endpoint here. That basically just pulls together a bit of data and creates a new process instance. I don't want to go through all of the code. That's not the focus of today, but you can see kind of the level of complexity. And if you're interested, you can dive into GitHub later on as well. And if I click here, that means a new process instance is kicked off that now integrates certain systems. So if I go back, I should see a bit of logging. Okay, I did some scoring. Now, one of the advantages of having this technology is that it can also look into what's going on in such a orchestration engine. So I see that I have that new process instance just kicked off here. And I can also look into the details of it. So I see it's already scored. You also see how long that take, at what time we entered there, a lot of audit data, for example. And you see we're currently waiting for a human approval. So now we have to pull in the people. That could be by using kind of a task list user interface where you have certain forms. That's not that interesting at the moment. So it's just clicking through that. Now the human basically approved, so the process instance moves on. If I go back here and refresh, we should see that this is now created in the CRM system. So it integrated a couple of systems. Now we can do one or two things actually to make that more interesting. The one thing is so this is actually the CRM service I'm calling, which is started in the same service. That's a great place to be. But for doing the demo, that makes it very easy. Now I want to simulate actually the CRM service is not available, for example, or it's faulty or whatever. So we can do not an HTTP OK, but for example, a service unavailable. So we get an exception when we call basically the REST endpoint. That's one thing that's interesting to look at. So if we restart that, right, keep that in mind. I do a second change at the same time to save a little bit of precious time here. And then, of course, I mean, the advantages of these process models are that you can easily make changes. So, for example, I added to the human task here, but it can do the same thing for integration use cases, for example, when waiting for a message or response message and that takes too long, or if you retry REST calls and that takes too long. So you can also have that matter of time where in this case I'm saying if the human takes too long, I'm doing something else like escalating. I make that a human task, just to get an idea how that's working. And then I say, okay, after duration of period time, 5 seconds. I'm a very impatient person. I do something else. It's dotted, so it does that in parallel. So there are a lot of nuances to the BPM language actually that are very interesting here. But that should actually work. So I restart my Java application. Now my REST service is faulty, and I adjusted my BPM process. And I'm okay in time. Good. So we enjoy looking at start. Oh, it's already started up. So there we go. I'm going back to my awesome UI, start a new process instance. We can look at our operate dashboard again. So we have a new version, a lot of side details here, so you can run, like process instance could keep running in the old version. We should approve. We didn't do that within 5 seconds. So we already have the escalation waiting here, but we don't care. So we can simply approve again. There we go. Now this moves on, and the create customer in CRM, we should see that probably on the console. I did approve. Oh, internet. It was not easy to get into the internet here in that room, actually. Okay, I'll show you that in a second. If the okay, that didn't work. The internet likes me again. Awesome. So that moves on. Creates a customer in the CRM system. That fails. That's expected. And now what you can see is what you don't see, or we could look it up in the log, but it retries a couple of times. That's actually configurable. That's a typical thing. If the service is not available, you want to retry it, right? Because REST services might not be available all the time. But after a while, it gives up. And then you have that so-called incident here. So that's something where you can look into. You have that on a top level. It's sorted by certain exceptions. So if one system goes down and whatever hundreds or thousands of processes are basically involved in that. You can find them grouped by the problem you have. Then you can look into that. You can go down to the really the instance level. Okay, you're making photos. I thought you fixed the internet, but okay, that's fine. So you really go down to the whole stack trace. Then we can fix the problem, and I will quickly do that just to make it to finish that. And then you can also like kick off retries, right? And I'm not going too much into detail right now here, but. So I retry it, and then it's now fixed, so the process instance moves on. And you have a lot of overview of that. And I'm not going into a lot of other patterns, but you probably can imagine that now in BPMN, you can also do a lot of patterns around, for example, sending messages, like really messaging, and then waiting for the response. If that doesn't come, you can do something. So everything that involves timing or long-running things in integration problems is actually pretty nice to do. Okay. So we fixed it, it's done. Cool. Now back to slides. I'm going back to the demo in a second. Okay. So what we just did looks like that. We have our Maven project over there. It has the BPMN file in there as a XML file. It has a client. We're using Camunda 8 SaaS here. And we have some custom code in order to connect to our REST endpoint. Cool. Right. Do a lot of things. If you're, and I'm not talking about that today because it's not a kind of a Camunda introduction, but if you're interested, you can talk to me later at the booth. That's basically what's running in the background. So the solution what we just saw is on the left, but the whole platform, how it's layout is here. We're normally running in Kubernetes, and then we have the core workflow engine, which is also horizontally scalable. We're streaming everything into Elastic, and then we have all those tools like Operate we just saw. We base on that. And you can provision that easily with Helm charts, for example. So that's kind of the gist of it. The idea here is it's relatively easy to set up, but at the same time, it's very resilient. We even have geo-redundant deployments, and it's also scalable. So we also run, for example, real-time payments on this kind of technology. So why I'm saying that is also, this is an integration talk. I framed it for integration. A lot of people ask me like, okay, I want to do system integration. This is like high performance. Yes, you can do that. Yeah, we're pretty cool as a company. We have a lot of customers. Awesome. So now the thing is, and that's pretty successful actually. We were doing a lot of projects also around integration with that technology. Now the question we get a lot lately is, okay, how can we make that quicker? How can we create these solutions much faster, like reducing development time and also involving more and more people? So basically, you are a rare resource. So most organizations lack engineers. They would want to have more, but they simply don't get them. And one of the ideas, it's not the only one, the one I want to focus on today, because that's the one that's mostly related to integration, is to, use reusable building blocks. It's not a new idea. The whole ideas of connectors, of saying, okay, if I have that second REST call, I don't have to code it, is not uncommon. I think the way we've now built that is a bit different than a lot of the, especially low-code vendors do that. And I want to go into that now. Because I find that super interesting, and I hope you too. So just to start with that. So for example, there's a marketplace. We also offer that self-managed for customers pretty soon. Then you can search for connectors, or you can just go through whatever connector you want to have. Some of them are provided by us, some of them are provided by partners, some of them are provided by the community. So we have also a very lively open source community there. And then I used SendGrid here as an example because I want to send an email. You could use whatever you want to. Then there is a connector. You can see what that can do. And then you could also install it into your environment. For a project, new project is typically what I use because that's a very speaking name. I have no idea. Make a copy. And then what you can see is now you get what we call an element template. I'm coming back to that in a second. It's basically the specification of the connector. And what's interesting here is that SendGrid, technically, and that's true for a lot of the services we see out there in the internet is REST-based. So if you want to use SendGrid, basically what you do technically is calling a REST API, but you need to know the right REST methods and stuff. And what's basically done here is that this technically uses REST underneath, but it basically hides it from the user and says, okay, we make it a SendGrid connector, and we have certain fields that are meaningful to the people that want to use SendGrid. And the rest is really hidden here in configuration. So for example, we should find something about the HTTP. Yeah, we don't go too far into JSON. And the interesting thing here, the next interesting thing is that if I want to, for example, involve other people in solution creation, they might not even be interested in we're sending emails with SendGrid. So logically, what you want to do in that integration is sending an email. It's SendGrid, okay, but I want to send an email. So what you could do, and you can also do that like company internal, you can even customize that more or build your own connector. So you could, for example, say, the sender is always hard-coded. So nobody can configure the sender because we know what we have as a sender. So you could say something like provide a value for that, and the sender is always Bernd. That makes sense, right? And we don't want to make it configurable, but we make it hidden. So it's not showing up in the, and then I have to remove something else where this is biting with. And now it's gone, but it's configured. And therefore you can really like reconfigure the whole experience, how it should look in the template. And that's actually what's the person later on building the BPMN model is seeing. Okay, so let's assume I progress with that, and then I can also control like where do I want to publish that? Should everybody has access to that or not? And as you can imagine, I prepared that a little bit. Switching back to my modeler, I could now add the sending email here, just that you see how that works. And it's a service task, but I now have all these connectors available. It looks a little bit different on our, what we call the desktop modeler, so the one that's running on my machine and just accesses an XML file, which I like here because then the XML file is part of my normal GitHub project, or the web modeler, which has an own repository and API. But I have a customized SendGrid, and as you can see, I really reduced it quite big time. So I just say, okay, I want to have the recipient name. There's expression language is also standardized. It's called FEA, friendly enough expression language. And then I want to send to the customer name. If I do something stupid, tell me, please. Customer email. We say your account was opened, and we say hello from J4. Great that. Nah. Okay, that should be good. I'm taking proposals if you like. Send email. And right, so that should be okay. I think that should work. Let's see. So I restart my application. What it basically does, by the way, the BPMN file is a resource here, and during startup it scans the class path, and then it uses an API to deploy that BPMN file to my orchestration engine, and there I should get a new version. So if I go back to operate, I should see my onboarding example in the version 3. There it is, right? And what I said early on, all versions still exist. Good. Back to my new account opening. Bam. I should see it here. I should see it here. Not my best day for a demo here today, but anyhow. So I already do the task. I complete it. There we go. It's already escalated. So it looks okay. Just that operator is not showing it. Am I in the wrong version? That's interesting. I filter for the error message. Thank you. You just saw that, right? You could tell me. I want to have all the instances. I filtered because I just went back and refreshed. But here it is. What you can see, it went through, and it should have sent me my email. Okay, awesome. Yay. I could send an email. Technically, probably not super surprising here, sending an email, yay. But I find the architecture idea super interesting, actually. Because what that means, if I look back to what we just built, I moved that piece of custom code over there, right? I can use that fancy device, to an own box and made it reusable and run it somewhere else. And by the way, I'm not going into all of those details, but what we call a connector runtime could run anywhere. So for all of the out-of-the-box connectors, we run that in the SaaS environment, but you could also run that local. So we very often run it close to the system we want to integrate. So for example, you probably don't want to open up the mainframe to the internet, so you run the connector runtime relatively close to it. It connects to Camunda in this case and to the mainframe. So there are a lot of options actually, but now you made it reusable and other projects can use it as well. That's the one option, and the other option is different roles could work with that. So if I look into the modeler and if I strip it down to a level where really, I would say people closer to the business can configure that, that's a big win in a lot of projects. And as a developer, I can control the connector code in a way. And the connectors, okay, there are a lot of out-of-the-box connectors, but the connectors are actually pretty controllable. And I think that's, philosophy-wise, a big difference to the typical low-code vendors. So we see that as an accelerator. That's a marketing slide, but I still like it. It's that knob of, you can still do everything in code if you like. You can run, I haven't showed you that, by the way, but there are a lot of things. You can run JUnit tests, right? So where you write a test case that includes the whole BPM file. There's a question, yes?
Can I ask now? So
yeah, why not?
aren't you kind of creating an anti-pattern by integrating these connectors directly into your process flow? Because I would prefer to have them loosely coupled.
Okay, that's a good question, actually. Aren't I creating an anti-pattern by integrating it into my flow? You would want to have it like extracted from the business process, what I do there. Then it would be kind of a send notification, I don't care what, right? Yeah, doable. It really depends a little bit on how you want to layer the architecture. That might be interesting to discuss later, but I think that could be a 1-hour discussion if we go into all the details. But also on a BPMN level, you have a lot of possibilities. For example, to have sub-processes where you can hide things, or call activities where you call another sub-process. It really depends on how you want to lay out the architecture. It could also mean that on this level you have just like microservice calls, like REST calls, for example, and that embeds the how do I do email. So there are a couple of nuances to that. But at some point in time, you have to do that technically. And very often that involves these, let's say, requirements for long-running things, like I want to retry things. I want to see it, the incidents, I want to see it in monitoring. These kind of questions, and then it gets interesting to have this capability. But as always, in short demos, you mix a lot of things. So I might agree, it depends. Okay. But technically, coming back to the connector idea, technically, the connector is like the worker code we saw before, plus a bit of UI parts to make it reusable. So it's not a magic black box. That's what I'm trying to say. So first of all the connectors we have are also source available or open source. So you can simply extend them if you like, or you can write your own ones. The most in the you can write company internal ones and then make it available. If you're more into code, that's the same slide in code. There is a link, a very tiny link, but you can find it. Looking into our own REST connector. It's a bit of code and the JSON for defining that properties. So it's not rocket science. That's what I'm trying to get. It's not locking any developer away, and nobody's forced to use it as well. It's really an offer to accelerate. That's kind of the idea. And it works pretty well, actually. And then the other thing, and I touched on that in the demo, just to recap that, There are connectors that always involve writing code. That's what we call the protocol connector. So it might be REST, or it might be Kafka, or it might be RabbitMQ, or messaging, or whatever. So all these kind of things that are really, let's say, on a technical protocol level. And then very often we base connectors on top of that. What I said earlier on, SendGrid is just REST, I guess. Maybe I'm wrong with SendGrid, I'm not 100% sure. But for example, Twilio is, I'm sure, or OpenAI is. So a lot of connectors are simply based on REST. Therefore, you don't have to write code. You could. If there's a good client SDK in Java, you can write it in Java, okay? But very often it's just based on the REST API. But still, this is a system connector, SendGrid. Logically, very often customers don't want that, but they want to have a logical connector, like sending email. We don't care what's underneath, because especially if I look at business people, they don't care if that's SendGrid. And I don't even want them to control it. That's exactly what like IT and engineering should control. What's the technical means, but sending the email. So you have a lot of control. That's what I'm trying to get at. And one of the motivations, and that's actually something I've seen so often, and it always makes me sad at least, a lot of organizations still work in certain silos around the, let's say, the business departments or the domains or whatever, however that's organized exactly in the IT. And what I see very often happening is that business, they have a lot of pressure nowadays. They need to automate. They need to automate a lot, actually. And if that's not one of the, let's say, the core processes, not in the heart of the company, but a lot of these long-tail problems, they simply need to automate. They need a solution for IT typically doesn't have the capacity. It's not that they find that nonsense, but we just don't have the capacity. We have other things that have higher priority. We have to go first, right? And then the business, and very often from an IT perspective, it's like, oh no, now they do that crappy whatever low-cool stuff there. We know that's not working. Yeah, but they try to help themselves in a way. I wouldn't see it as they try to make IT angry, but they're trying to solve certain problems to keep the business alive, basically. And I see, and if we look at what we call solution creation. So if I want to automate something, if I need to do certain integration solutions, we have a lot of people involved. So there might be core developers, Java developers, Spring Boot experts, whatever. But we have all these other kind of roles, and it's very diverse, actually, what we have there in most organizations. And the more people we can involve in solution creation, the more we can automate. That's kind of the simple idea here. And an important thing to keep in mind here is that also the integration problems we have are very diverse. So we might have certain core processes, like if I look at a bank, it might be around payments or trading, depending on what kind of bank you're. Or, for example, also customer onboarding. I would see that as a core use case. It's very often not very simple. It's very critical. And it's also very complex in a lot of use cases. But then we have other things which are getting more simple. I had long discussions if address change is simple or not. That might be really complex for some companies, but I put it somewhere in the middle. But you definitely have a long tail of simple things, right? And therefore, you might not have the exact same requirements around quality and governance and whatever. The important thought here is now you have to think about that and make that very, very conscious decision about what to use. So you might want to categorize these use cases. And that's something this slide is inspired by Shell, the oil company. They do this in 3 buckets, and I see very similar categorizations with other companies, by the way. They have the very critical core processes. They put it in a red bucket. That's always professional software development, like what we know, right? We want to have a CI/CD, we want to have proper testing, we need to version it, and so on and so forth. Software engineering, clear. Then they have green use cases, which is kind of, okay, some business users help themselves with whatever, Microsoft Excel, or we don't care, which is also okay. It definitely says kind of, we don't care. If it breaks, hey, they have to redo it. We don't care. We let them do that. But then there's this middle bucket of what they call yellow use cases, which are not that critical, but also they do matter to some extent. And that bucket is super interesting to look at, because for the others, it's clear we do professional software development. That's we. We let them do whatever they want. That's them. But what do we do in the middle? And what I find interesting, and that's why I love talking about that at actually developer conferences. If we do something what I sketched earlier on with the, let's say, very controllable connectors, we allow that the developers basically are still in control, but they can enable more people to take part in these projects. And that might happen. We see that in different ways. So you might have a kind of a center of excellence, which creates connectors that others are using. That's one way. But it also could mean in one project, you have that one engineer, but other people then doing all the processes, the BPMN models. And by raising that bar, that abstraction, you allow them to take part. At the same time, you don't give up control as a developer. Because the alternative, and that's what I'm also seeing, is that basically the tools from the green side of the equation are moving towards the yellow space. And if you go too far, that's really dangerous. Then you end up with a solution there that's not tested, that might have security flaws because nobody thought about that, and so on and so forth. So I find it much more interesting to come from the red side and moving towards the yellow by making it easier, but not locking anybody away. That's kind of my thinking about that. And that's why I also find low-code interesting, doing that in the right way. Because then, and we're doing that with more and more customers now as well, where they have that kind of capability within the IT organizations, typically like a center of excellence. They provide a self-service for their customers, like, okay, there's a Camunda instance, we have those connectors to our core systems, you can use it like that, and then business can do certain things on their own on top of that. It's better than using that, whatever kind of shaky low-code platform. Okay, right, I talked about that. Good. There's one, I would say, elephant in the room typically. I used that slide quite a lot over the last, 5 or 6 years when talking about microservices. That's a metaphor I learned from Eric Evans, the one that wrote the domain-driven design book. It's a 3-legged race. So 2 people are always bound together by their feet, and then they run like a game. And what you can see there is that, or you can imagine, everybody runs slower than they could if they run alone, and the risk of falling down is much higher. And that's kind of the metaphor of why we want to do microservices. We want to decouple teams. We want to make them autonomous, because then they can run on their own, right? Then we're faster in development. And kind of that whole idea around microservices led to a really, let's say, high value around decentralization. I see that a lot. So with certain things around running, providing a platform, probably providing a center of excellence, providing certain connectors for the company, isn't that too centralized again? That's kind of the discussion I'm having very often. So I wanted to go into that really quick. One blog post I really liked was, I think, 2020. Yeah, 2020. It's from Spotify. And they wrote about basically a lot of the experience they had with microservices. And they came up with a concept they call Golden Path, which is kind of, if you have a certain problem, like whatever, I want to provide a customer-facing web application. Then they have kind of a default stack they use, like technology-wise, how to set it up, how to test it, and so on and so forth. And they do it, that's why it's called golden, right? They do it in a very nice way, so it's really prepared, it's golden, so it's easy to use. As a developer, it's kind of pulling you into that, because, oh, before I think of my own thing, I just use that, it's so easy, it's so cool. But they also wrote in that blog post that they found that rumor-driven development was simply not scalable. These kind of, oh, I heard that team is using that technology and it seems to work, so we probably also should use that, right? And what they now set up is a project they call Backstage.io. I have no idea if the tool is good, by the way. I've never used it, so it's not a recommendation for Backstage.io. It's probably good, it's probably not, I don't know. But if you go to the website, they have something on there which I found really spot on. They talk about the speed paradox, which they say at Spotify, we've always believed in the speed that comes from having autonomous development teams. But as we learned firsthand, the faster you grow, the more fragmented and complex your software ecosystems become, and then everything slows down again. And I see, yeah, it's the same here. I typically see nodding when I say that, because with a couple of years into microservices, a lot of companies are actually experiencing that. And they say the standard paradox is by centralizing services and standardizing your tooling, Backstone streamlines your development environment from end to end. Instead of restricting autonomy, standardization frees your engineers from infrastructure complexity. And I think that's something everybody should at least think about a bit more. So there is a healthy way of centralization to some extent. Team topologies, the book is pretty spot on as well. That got quite famous relatively quickly over the last 2 or 3 years. They define basically, certain team topologies that work well in modern organization. And one concept they use to explain that is cognitive load. So cognitive load is you only can solve a certain amount of problems at the same time in your brain. It's just a limited capacity. And you have to decide on what you want to spend that. And there are different types of cognitive load, for example, the intrinsic around the fundamentals. So if you already know how to program in Java, what Maven is and Spring and so on and so forth, then you reduce that because you're familiar with that. That's typically done by education or training or whatever. And then the extraneous is around the environment, like how do we set up products here? How do I deploy that? How do I get my cluster to deploy? That's typically can be reduced by providing these kind of golden path and then saying, okay, this is the way we typically do that. And then, or platforms, right? That's kind of the typical thing. And then you have more capacity for the domain cognitive load, which is the real task, the business problem, the problem you're trying to solve, which is something companies should aim at. Okay. I find it such an important thought. So going back to that picture, for me, it always feels a bit like understood wrongly. So of course, we wanna not isolate, but giving the domains autonomy, right? We want to separate them. We don't want to tie them together, but we don't want to let them stitch their own sport shoes or stuff. That doesn't make much sense. And very often I see exactly that happening. Okay. And especially if we're looking, maybe that's my own bias, but if we're looking into end-to-end processes, it's very often also a problem if we give teams too much autonomy. Nobody's looking at the end-to-end process anymore. And if you optimize locally, that very often not leads to optimized overall processes. Let's look into that quickly. Kind of the last slides here. Should we do that event-driven? That's the other elephant in the room typically. Okay, you talked about that orchestration and we can integrate systems there nicely and we can retry and we have an overview. Okay, that's cool, but that's not hipster enough for us. We want to do it event-driven. Isn't event-driven the call of the day? And because then you have these nice choreographies and you can add systems and a dancer and it works just nicely. We can look at that, and I have the same example. I wrote an article for InfoWorld quite a while back using the same example around bank account opening, and then you could have, for example, different microservices, and you want to basically implement that event-driven where you say, okay, there's some event entering, like the customer just register for a new bank account, for example, and you want to get that to an end event in a way, but to an event where the customer has bank account opened, for example. And of course, you can do that event-driven. It looks a bit like that. You have an event bus, maybe Kafka, maybe something else, where you say, okay, I push an event on that, like customer request registered. Then you have different services that need to be integrated in order to do that. For example, the credit check. So this could listen to that event saying, okay, now I do the credit check and now the credit is checked. You might want to do the address check after that. So the address check is listening to that event. Does it work? Next event is published. Then maybe some customer, customer management microservice is picking that up and the customer is registered. So we're good. So that's kind of what I call an event chain. It's kind of a flow over events. And that's what I'm seeing actually regularly in microservice environments. Because it looks so decoupled. It's not decoupled. That's the one thing you have to be aware of. You still have the coupling because you want to have a certain sequence here. That's normally the next discussion. Yeah, but this is stupid here with that sequence over there. Why are you doing that? Yes, of course. And by the way, back to the problems in the beginning, I don't see what's happening. How is why does that take so long? Where is the time spent? I have no idea. That's why I can go into a lot of observability talks around that. If I want to add a new check, and that's something which is not totally made up actually, you have to have new checks, and there's compliance, regulatory requirements around that. Then you really have to like unwrap that event subscription, basically add the new service, subscribe to that event, have a new event. So you have a couple of changes here you have to make, and you have to coordinate those changes to deploy them at the same time, to think about that. So it's not simple, that's what I'm trying to say, and it's not that it's only local in one service, because it's really looking at the flow. It makes things very complex. And then sometimes people say, yeah, but it's not a good layout of your event subscriptions, you should do that differently, do that in parallel and whatever, then it gets much easier to change it. Probably it does, but it changes the business logic. And I'm maybe not allowed to do that, right? And especially if I want to add stuff, it gets still complicated. So what I'm trying to get at, and if you want to now change the sequence, it's all messed up. And that's a problem a lot of companies currently run into, because they started with that, they wanted to have it such a decoupled great architecture, and now they want to do changes and they see that it's really hard to do. So it's not exactly that picture what I'm typically seeing. It's a lot more chaotic. Good. And I'm also seeing people talking about that. That's getting more and more. Like 3-5 years ago, that was uncommon because people were still in the, oh, we have to figure it out, it's our fault. Now people are much more in the, oh no, that's a fault in the architecture style. There are probably good uses of choreography. I'm having a whole chapter in my book about it, but there are also big risks. Right. That's Phil Calzado. He was working at Meetup back in the days, and he talked about that as a pinball machine architecture. I like that metaphor of ding, 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 events bouncing through the systems and nobody know what just happened. And instead, you could also do orchestration. And by the way, that doesn't mean I switch to synchronous blocking REST calls or whatever. It just means I probably have orchestration logic, and these services here might not react to certain events directly, but they might receive certain commands, for example, probably also via Kafka if you want to do that, to do something. And then you have the overview of what's happening in one place, and you can change it in one place. And back to the centralization, and that was a conscious decision. I didn't make a own layer, the process layer or the company-wide process layer. It's orchestration logic, but it's part of the customer microservice. That's totally doable, right? So it's not, in that sense, centralized. It's just expressing it in one place. Okay, yeah. The way I'm seeing that is really you should have, to some extent, both. And if you don't balance that out, orchestration, choreography, event-driven, and other stuff, that might get shaky, and you end up in the chaos bucket. Okay. Yeah, as I said, I have something in the book about that. I have 2 minutes left, so that's something I needed to add. It's like, hey, you haven't talked about AI. We're at 2023. ChatGPT is there. Have you heard? Yes, of course. If you're interested, we're also, of course, working a lot into that. It's pretty interesting, actually, around especially the Copilot thingy. So I'm switching the text. I'm going for that. So there's an URL. You can try it out. So we already have something to assist you with modeling. That's one thing. We're also looking at building connectors. So you could imagine something around where, for example, you have an open API specification. Open API specification, and then you can build a connector based on that with a bit of chatting or stuff like that. We're experimenting with a lot of that to make solution creation even easier. That's pretty cool, actually. And the other thing I wanted to quickly talk about, because I had a lot of visual, shiny stuff here, people then sometimes ask me, hey, I know Camunda from a couple of years back, and you always talked about these highly scalable things, like millions of process instances per second. I don't hear that anymore. Is that something you don't? No, definitely not. It's just something we figured out, and it's working. It's kind of the backbone of the tooling, so you can do everything in high throughput, geo-redundant, whatever. yeah, we do a lot of measurements. We just reduce the overhead, for example, latency-wise for every of these service tasks you can see in a model to a low, depends on the exact thing, but a low 2-digit millisecond number, typically, probably in a 1-digit number. So there's a lot going on. That's what I'm trying to say. With that, I leave you with the ask or the opportunity to try it out. You could probably guess the link yourself, but there's a trial version for the SaaS account. There's an installation instruction how to run it on like, for example, on your own Kubernetes or with Docker locally, for example, Docker Compose. So you can simply try it out. Thank you very much.